Here we are with the Chapter 5 review exercises, numbers 34 through 39. We are solving by factoring. Now, notice when we solve, we can't use anything that we used in Chapter 2. Well, we might be able to a little bit at the end, but mostly it's a totally different attack of the problem. We get it equal to 0, then we factor it with the 5 methods we learned earlier, and then each piece has to equal 0. So, right here, let's go through and factor this. Wait, did we get it equal to 0? Yes, equal to 0. So we can start factoring. Greatest common factor. Yep, we can pull out a 5. Then we have x squared plus 4x plus 4 equals 0. And then this factor is what adds to, oh, it's a perfect square. 4 and 1, x plus 2, x plus 2. All right, so that gives us 5. Does 5 equal 0? Nope, that doesn't give us an answer. How about x plus 2 equals 0? That gives us x equals a negative 2, and so does this one. When x plus 2 equals 0, we get x equals a negative 2. So negative 2 actually happens, but it happens twice as an answer. That's kind of fascinating. So just one answer of negative 2, but it occurred twice. All right, number 35. Get it equal to 0, step number 1. So we've got x squared minus 25 equals 0. Now factor it. This is a difference of squares. So we get x plus 5 and x minus 5 equals 0. Set each piece equal to 0. So x plus 5 equals 0, and we get x equals a negative 5. X minus 5 equals 0, and we get x equals a positive 5 when we solve that. So I guess we do use a little bit of chapter 2 stuff in there. That's kind of fun. So negative 5 and 5. All right, 36. Step number 1, get it equal to 0. Check. It is equal to 0. Now we're going to factor. It is a trinomial with a leading coefficient 1, so this can happen in one step. Let's see, negative 40. What can times up to negative 40? 1 and 40, 2 and 20, 3, nope, not 3, 4 and 10, 5 and 8, 6, 7, nope. All right, what adds to a positive 3? It looks like a positive 8 and a negative 5. Well, times it good. So we get x minus 5 and x plus 8 equals 0. Now, since they're multiplying to 0, we get that either x minus 5 equals 0, which gives us x equals a 5, or x plus 8 equals 0, and x is a negative 8. Oh, yes. Good. Number 37. Oh, the cruelty. The cruelty. Do you see these are already factored, but is it equal to 0? No. We have to multiply these guys out. 6x squared plus 12x plus 5x plus 10 equals a negative 2, and then add the 2 over here. So we get 6x squared. Let me see, that's plus 17x, and then add the 2 over, and we get plus a 12 equals a 0. So we have to get it equal to 0 before the factoring is helpful. So now we're going to factor this. No common factors. 3 terms. Leading coefficient is not a 1, so this one we have to do 6 times 12 is a 72. A 1 and a 72, a 2 and a 36, a 3 and a 24, and a 4 and an 18, and a 5, no, a 6 and a 12, 7, 8, and a 9. Do any of those add up to 17? And shazam, an 8 and a 9 do. So this is 6x squared, split b. That's a plus 8x and a plus 9x plus 12. So we split that guy up. And now we have 4 terms, grouping. Chainsaw that guy, cut it down the middle. We take out a 2x, and we get 3x plus 4. And then take a 3 out. And we get 3x plus 4. Take the 3x plus 4 out, and we're left with a 2x plus 3. That was a long factoring, and we're still all equal to 0. This whole thing is equal to 0, but now look at what we have. 3x plus 4, step 3, each piece equal to 0. 3x plus 4 equal to 0 will give us an answer. Subtract 4 over, and we get x is a negative 4 divided by 3. And over here, 2x plus 3 equals 0. Subtract 3 over, and we get x equals a negative 3 halves. So those are the two numbers. And if you ever have some fun time on your hands, go ahead and stick -4/3 right there and right there, and they will actually times to a -2. If you take -3/2 and times them right there, it'll also times to a -2. But we had to go through this 0 to make it actually come out. Crazy. All right, number 38. Is it equal to 0? Yes, we don't get stuck in that mess again. Equal to 0, good. So let's factor. It has two terms. They are perfect squares, and it's a subtraction sign in the middle, so excellent. 11y minus 5, 11y plus 5 equals 0. So each piece equal to 0. 11y minus 5 equals 0. Add 5, and I get 11y equals 5. Divide by 11, I get y equals 5/11ths. On this one, 11y plus 5 equals 0. And then subtract 5, y is going to equal a -5 divided by 11. Alrighty, those are the two answers on that one. And now the last one, 39. All right, is it equal to 0? Yes, it is. So let's factor it and get those individual pieces. Leading coefficient is not equal to 1, so 2 times 12 is a 24. Positive 24, so 1 and 24 will times to that. 2 and 12, 3 and 8, 4 and 6. And which of these add up to -11? It looks like those two. If we have a negative and a negative, let's double check. -3 plus -11 is -8 is -11. And -3 times -8 is indeed positive 24. So we get a 2x squared split b -3x -8x and plus 12 equals 0. So we now have four terms. Chainsaw. What can we pull out of the front? That's x times 2x minus 3. Good. And out of the back, we'll take a minus 8 and 12, 4. And we're left with 2x minus 3. Good. Oh, look at that. The 2x minus 3's are there, so we got x minus 4 times 2x minus 3 equals 0. So we have x minus 4 equals 0 and 2x minus 3 equals 0. That's the power of multiplying to 0. If one of them is 0, you have an answer. So x equals 4 and 2x equals 3. X equals a 3/2. Okay, good deal. There's 34 through 39.